Okay, so tonight we're going to do the quadratic and the rational inequalities. Now remember what I told you, you also do it in school, okay? So be careful, we're going to do a different method, but this is a nice method to do complicated stuff. But you must please stay with me and you must listen and ask your questions because I don't want you to get confused because of the reason you're going to do two different methods. And yes, we don't want you to be now totally confused. Okay, so ek gaan nie alles in die boekie doen nou nie. Julle kan dit mos maar deur gaan en vra. I'm going to do the important stuff. So I'm going to scroll up a little bit, but let us just stand still here for a moment. You see this number number A here, that's a nice school sum. But if you this is a nice one that you will also have in school, but when you get to something like this, that can be a problem. Okay, now most of you, let me just I just want to show you here something quickly. So say now we do a little number line there. And we have now, remember, we always look at the 0 points. The 0 points. That's very important. Afrikaans noem ons dit die 0 punte of die 0 punte. Jy moet maar hoor hoe julle onderwysers praat. Dis ook die oplossings, it's also the solutions and so on. But remember, when we have equal to, if we have like x plus 3 is equal to 5. Then we have x is only like 2. That's easy. But if we have x plus 3 is greater than 5, that is a total different ball game because there can now be millions and millions and millions of answers. So that is the problem. So that's why we need to tell people when are we working out the 0 points and that we're not busy with the inequality. Now when we look at something like this, we'll have a 0 point there of negative 4, and then we will have a 0, it looks like, just help me that I don't go wrong. We'll have like a 0 there, we will have a 2 and a 4, I think, a 2 and a 4. Do you agree with that? Hello?
Ja, meneer.
Yes, it's the 0 there, it's the 2 there, it's the minus 4 there, and it's the 4 there. Okay. Now remember now, some teachers will now somehow go and they will say it's positive, negative, positive, negative, positive. And you cannot do that. That is totally wrong. And that's the problem because some teachers start at the right hand side and they go plus minus, plus minus, plus minus. So honestly, the best method is to check what is happening inside there. So I've put the steps here on the right hand side in the notes so you can go through the steps, but let us just quickly look at how this method works. So what we will do is, we call it actually in university we call it the boundary points, but you can call it also the the 0 points. But we actually talk about the boundary points because they form boundaries here on the number line. Alright, so wat ons dan nou eers gaan doen is om dit uit te werk en dit is nou hier, ek het vir julle hier in rooi gewys. So dit is om die is gelyk aan eerste uit te werk. Okay, en dit kry ons nou as 3 op 2 en min 4. Is almal by daar? Are you all with me there? Hallo?
Yes, yes sir.
Okay, so now we have our 3 over 2 and we have our negative 4. So here is the negative 4, there's the negative 4, and there's the 3 over 2. So we have, the important thing to note here is that we have 3 regions here. Region 1, region 2, and region 3. Because we have two points of basically separating. We have that there and we have that there. So that separates it into 3 regions. Now, honestly, the best thing to do is to take a number and check what is happening there. In other words, we go to region 1 and we find a number inside region 1, like the -5. We substitute it into our original equation and we check what happens. And we see we get 25, but that is not less than 12, so that gives us a false value. Then we go to region 2, find any number in region 2, any number. So I took 0 here, because it falls into region 2. And then I saw 0 is less than 12, so this makes it true. And then I find any value. Now, if you use the table method on your calculator, or the table mode on your calculator, then this is very easy, because you can put in your equation on the calculator, and you can just check what happens in the regions. So it's very, very easy. But otherwise, you don't look. I've showed all this. The test 5, test 0. You don't have to show it. You do not have to show this. This is to explain. Okay, but anyway, if we take a number in the region 3, then I see 2 falls into region 3. I could have taken 3, 4, 5, 6. I could have taken any one of them. Okay, and then I see 18. If I substitute again 18, which is not less than 12, so this is false again. Okay, so the only place that it is true is then between the two places there. So therefore our final answer is going to be inside between -4 and 3/2, because that was where we had the true. So here it is in set builder notation, and here it is in interval notation. You must know both, né? Okay. Kom ek hoor gou of julle by is. Enige vrae, any questions here? Is julle okay?
Ek hoop so.
Yeah.
But you're still fine, eh?
Yeah, still fine.
Okay, wonderful. Okay, so let's look now at the second one here. Okay, so here we had that one we were just discussing just before we got here. So to the second one, it's number B now. We did it in the first part there, and there we had those 4 places on the number line that we did in the first one. Okay, so the problem here, the one that we must be careful of, is this square here. That's the one that is giving the problem. So we must be very, very careful. Okay, so let us look now. So it divides it up now into 5 regions, because we have 1, 2, 3, 4, 5 regions here. So now we take any value in the first region. We took -5. And we saw that it is false, because -315 is not greater than 0. Okay, then we go to the second region. We find any value there. We took the -1. Substitute it in. We see it's false again. You see? So now you don't get plus minus, and stuff like that. Then we take the next region. We can take the 1 there, and we see, okay, but this is true. This gives true. Okay, so we can say false there, and there we have a true. Now we go to our 4th region, and we can take a 3 there, and we see false again. And then we can go to our 5th region. Okay, take a 5 there, check what happens. It is true. Okay, so here we have then a false, and we have a true. So our answers is then going to be where it's true and where it's true. Okay, so our final answer is then going to be between 0 and 2 and greater than 4. Or if you write it in interval 0, 2, and means or, so you can either write or, like we did here, or you can write a semicolon if you want to, or you can write the symbol for or. Okay, so look, so I mean, if we just go back there, and we see we had false, false, true, false, true. So we don't have, so in the positives and negatives, it would have been negative, negative, positive, negative, positive. So there's not positive, negative, positive, negative, positive. So we must be very, very careful when we do complicated ones. You can't just do the parabola and do a positive and a negative and a positive. You need to check what is happening inside there. Okay. So, so far so good. Are you still all right?
Ja, meneer.
You following?
Yes.
Okay. So even if we have one that we need to use the formula with, because remember you at school you have done now this work, that's why we waited a bit and did the finance first. So in school you people did this, that you had to work out with a formula, ne? You with me?
Yeah.
Okay, so you know the formula. So remember, we're working out the boundary points. So call it the boundary points. You can write here BP for boundary points, or you can write 0 points or whatever, and that is when you do the equal to 0. So be careful, please. You cannot do any of this with the inequality. You must first go to the boundary points. Okay, we work it out. So even if it gives us decimal values, that doesn't matter. We must just find where it is on the number line. So again here, we will have our 1.56 roundabout here. And we will have our minus 2.56 roundabout there. And then it was separated into 3 different regions here. And then again, we take any number in this region, minus 3, check if we get a true or a false. Take another number in region 2, so we can take 0 there, and we see it's false because negative 4 is not greater than 0. And then we take a third one in the third region. We can use 2, we can use 3, we can use 4, we can use 5, we can use anything. Okay, I took 2 and I checked and it gave me a true answer because 2 is greater than 0. So once again, here we have now true and we have now true. Okay, so here it's indicated. So we have our true over here and over here. So it's less than 2.56, minus 2.56. It's less than that. And it's greater than the, what was it, 1.56. Okay, so you can write it in decimal values, or you can write it with a third form like here, but I think it's easier to write it in decimal values. So you will just write x is less than equal to negative 2.56, or x is greater than 1.56 or something like that. Volg julle nog? Hallo?
Ja.
Julle volg nog, okay, mooi. Mense, alright, so daai is nog so 'n bietjie skool. En hierdie eerstes is ook nog bietjie skool, maar ons wil eintlik nou kom by die rational inequalities. Dis eintlik waar ons nou wil wees. So actually here is really where the AP starts now. Okay, we want to look at the rational inequalities. Now remember, rational means fraction. Okay, so we want to look at the fractions. Okay, so in other words, how do we handle something like that now? Alright, how do we handle that now? Now here's the problem. When we have something like x plus let's say 2 minus x is greater than 3. Okay. Then we will have negative x is greater than 1. And then we will have x is less than minus 1. You see, we have a symbol change here, and that is the big problem. So when we divide, we have learned that at school, so it's not new to us, but it's the understanding that is important. So we have learned in school that when we multiply or divide with a negative, the sign will swap. Okay. So that is why we cannot now, if we have x plus 2, right, over x minus 4, less than or equal to 3. I'm going to ask again for the sound. Somebody is really not helping us with the background sounds there. Okay, so we cannot now multiply with the LCM. Okay, we cannot do that. So x plus 2, you cannot say this. Because of that reason at the top there. That how do you know now when you multiply with x minus 4? If you now multiply with this x minus 4, how do you know that it's positive? Because you didn't change the sign here. So you are taking it for granted that that is now positive, and nobody knows it because x is an unknown. So we don't know what x is. So we cannot say that this symbol will be less than or equal to. If it was negative, we should have changed the sign. So we can never ever do something like this. And in AP Maths, if you do it, you will get 0. We won't even look at your question anymore because it's a total rubbish in maths. We cannot do that. And that is the reason why we are applying this method, the boundary points method, because this makes it easy for us. Okay, so when we apply the boundary points method, what we do is we go work out the boundary points first. Here we go. And for that, we say it's the boundary points, and therefore we can put an equal there. Because we are, or you can also say 0 points, but I think stick with boundary points and there's no confusion. So we are calculating now the boundary point. And because we are calculating the boundary point, we don't worry about any sign, we don't have a problem. And that is an easy sum to work out because that falls back to grade 9 and 10. So now we can multiply with a common multiple, with the x minus 4, and we get a very easy equation sum here. This is easy for, okay, I'm going to just take the highlighter rather. This is very easy for us. There's nothing funny in that calculation. I mean, this part here is really not difficult to work out. Okay, now here comes the catch now. So if we go to the number line now, and this is the thing that you must now understand. And if you understand it, then it's easy. Okay, so when we go to the number line, sorry, I just want to get us a ruler here, a line. Okay, let's put the line there. All right. Okay, so I just want to go back to the black there. Okay, and then I want to choose the orange. So here is our 7 now. There we put the 7. Okay. Now, what you must remember now, when you indicate on your number line, the rule is the following. So on the number line, on your number line, your rule is the boundary points comes on the number line and the denominator equal to 0 comes on your number line. So if we go back a little bit here, we will see that the denominator equal to 0 gives us 4. That is where the problem is. It doesn't exist at 4 because we cannot divide by 0. So x cannot be 4. Because if x is 4 there, we will divide by 0. And that we cannot do in mathematics. So we have then two things. We have a boundary point and we have restrictions. And that's how easy it is. There's nothing funny. So we have the boundary points, okay, and we have basically our restrictions here. You can say this is the restriction. The restriction is where the denominator is 0. And in our example, that is where x is 4. So it's where x is 4 is the restriction, and we have the boundary point as 7. So the restriction is 4 and the boundary point is 7. And now we can put the boundary point on the number line, and you also put the restriction on the number line. That also comes in here. And there you have now your 3 regions again, and you go check. So here in region 1, for instance, you can take 0, and you see that, let us move it up a little bit, you see, that is not, that is true. That is giving me a true value. Then we can take 5 and we check our fraction and we see, it's false. And then in the third region we can take 8 or 9 or 10 or whatever you like, and you can check and you see it's true again. So here we do get the true, false, true, or the positive, negative, positive, but the true, false, true. And your answers will always be the true ones. Now just remember, when you indicate on the number line, you can never have the 4 inclusive, because remember that was the restriction. So this 4, if you put it on the number line, you can never include it. Alright? It cannot be included. It's always open. The 7 you must see if it's greater and equal to or less than equal to, that's going to be a dot because it's included. But we can never include the restriction because we said we cannot divide by 0. Okay, so if we now go to our answers, alright, we will now see that the 7 is included, and the 4 is not included. So not included like that and included like that. Or you can use the method of a dot and a hole. So for included, you can make a dot. You can make a dot. And for excluded, you can make a 0. Is it clear? And then it was true here. And it was true there. So x is less than 4 because it's not included. X is greater and equal to 7 because it is included. Any questions? Enige vrae?
Sorry, sir. This might be a stupid question, but I just want to make sure. What is that you tested there, sir?
You go to your original equation. Your original question basically was, where is this bracket less than 3? Less than equal to 3. That is what you must solve, not so?
Yes, sir.
We need to solve where is this fraction less than equal to 3. You with me?
Yes, sir.
Now I found the boundary point and I find the
restriction.
Yes. And now I'm testing inside my regions. So I'm going to region 1 and I test now any value inside that region. Okay, I decided on the 0. And now I check if this is less than 3. And I see it's true. Because
okay.
my original equation must be less than 3.
Okay, thank you, sir.
And then I go to the 5 and I see, no, that's not true because the left-hand side works out to be 7. That's not less than 3. It's false. And 8 works out to be 5 over 2, 2.5. Well, that is less than 3. So that's true again. And I need to give my true for my answers.
Okay, thank you very much, sir.
Yeah, but you must ask your questions. I appreciate the question. Anything else?
Sir, I just want to say maybe we should all go on mute besides you so that we can stop the feedback from happening.
We must do that, yeah. And then if you talk, if you want to ask or talk to me, you just put your mics on.
Okay, thank you, sir.
Yeah, that's going to be because there is a back feed. I don't know why, but there is. It should not be. I didn't have it this morning. So it is somebody in the group that has more than one thing on or something. Okay, that makes the feedback. Okay, you mustn't go 2 and 3 together and put everything on. It's not going to work. I don't mind if you sometimes 2 or so, but like a brothers or something like that, and you sit together, but then there must be only one thing on. Otherwise, it makes a feedback. Okay, but guys, listen here. We're here to help you. Okay, listen, just a moment. You understand where we are now, ne? You do understand this.
Yes, sir.
Okay.